my presentation will be on internet banking and the threat of malware. I'll be speaking on Hesperbot, which is a Trojan malware, which came out about 3 years ago. Introduction: Trojans in internet banking. A Trojan is a piece of malware that comes across as a lookalike or a twin of a legitimate piece of software. At face value, the software resembles a well-known program. However, behind the scenes, it is filled with malicious intent and content. There are many types of Trojans, including dropper Trojans, ransom Trojans, and fake AV Trojans. But today I'll be speaking on a banker Trojan. Here is a quick screenshot that I made of what a Trojan will look like. It looks like a legitimate Word document attachment, but really and truly it's an executable file. It has a .exe um, extension. So Hesperbot mainly was used to attack parts of Europe. Thought to initially discovered in August of 2013 in parts of Europe such as Czech Republic and Portugal. Hesperbot, aka Win32 Spy.Hesperbot, has a wide range of tools in its arsenal. WeLiveSecurity.com mentions that the diversity of weaponry used is quite remarkable, including things such as the ability to log keystrokes, capture video, create screenshots, HTML injections, and also setting up proxy servers to intercept and modify altered data. Lastly, Hesperbot is also able to set up virtual network computing servers, which allows the attacker to log in and share the desktop of the victim, similar to the remote desktop where you can log in from a remote location. So this is all done behind the scenes without the actual victim knowing that someone is logging into their computer. And here are some of the online banking websites that were targeted in Czech Republic and Turkey. So Hesperbot at first glance. So if we were to go to, let me grab, I have a MD hash that I was able to get we from WeLiveSecurity.com. If I grab this and go to Virus Total, you can take a look at it here quickly. We can tell, well, right away we can tell that 18 AVs found this to be malicious, which is a good sign. Um, if you look at the entropy, you can see it's relatively high because out of a score of 8, 6.68 and 7.26 is considered to be pretty high. So our data pretty much contains read-only data. This one is almost a score of 8. So you can tell that this data is either compressed or packed. The dot text that generally contains the actual code of the program. That too is, as I said before, it's pretty high. Um, let's look at I'll come back to that later. But so Hesperbot also creates mutexes. Now a mutex is it allows it's kind of a way to prevent a program or piece of malware from conflicting or causing collisions. So if a piece of malware requires one module to run, complete that process, then another module to run, then by having a mutex, you reserve a spot so that there's no collision. So it says here, additionally, it has a wide range of mutexes which are created to avoid any collisions if more than one instance of the malware tries to run at the same time. So if we look at virus total, we can tell that this sample did indeed create quite a few, about 7 or 8 or 9 mutexes. So how was Hesperbot able to infect its victims? First part was social engineering through email. So victim gets the email, they click on it. It has an executable file. Even though it says .pdf, it really is an executable file because it has a .exe at the end. Um, then the dropper component conceals the core, which is this part here, drops it into the explorer.exe because this malware was pretty much designed for Windows operating systems only. Um, so attacks in Czech Republic was able to trick users into thinking that a file named zasilka.pdf.exe was a legitimate PDF file containing tracking information for a postal package. Similarly, in Portugal, targets downloaded an executable file which was sent to them through email. This executable file had an extension of .pdf.ext, but really and truly .exe, with the intention of masquerading as a PDF invoice. So the dropper component uses the create remote thread function, and this I found this on reliveSecurity.com. This it uses that function to inject its core into the Windows operating system. So the Explorer.exe process. Create remote thread simply creates a thread or pathway that runs in a virtual address of another process. So it kind of hides itself within a legitimate process. According to Practical Malware Analysis, the hands-on guide to dissecting malicious software, which we're using in class right now, launchers and self malware use create remote thread to inject code into a different process. This helps to hide intent. Alternatively, Hesperbot can use the attrib.exe process to initiate Windows Explorer.exe. Then it uses the write process memory function to point back to the malicious code within the core component. I found this on virustotal.com, and you can tell that this created and injected the attrib.exe process. So the core component, okay, after being successfully injected, the core then takes charge of dialing home to the control center to summon other needed components such as plugins or modules. So after it gets into the victim system, it needs to complete the full attack. It needs some backup. It needs to call in for reinforcements or the remaining components to make the attack successful. So calls home to these. What it does, it generates randomly uh, named domains, kind of I think it was used to avoid detection. So here is one of those domains that it dialed home to, and I was able to plug that into VirusTotal to see if it was known to be malicious, and 3 of the online AVs found it to be indeed malicious. So the core data, when inserted into the victim's operating system, creates folders and files with random names. This stored data can then be inserted into any running process, as stated earlier. These folders are also later used to store intercepted data such as information captured by keylogger. So more than likely you'll see like usernames and passwords in there, or computer names, any data that they need to allow the malware to function properly. Like maybe IP addresses, stuff like that, so that when it dials home, it knows where to send that data back to. I found this on Microsoft.com. This is a pattern or an example of the pattern of that folder that I've created. So as mentioned earlier, Hesperbot can also create screenshots and video and inject malicious code into the web server. This is done through 3 main modules right here. After the NetHK module sets up the proxy in the client's browser, the HTTP module steps in and analyzes the data caught in the proxy, and the third leg of the relay finishes with HTTPI modifying the malicious data. Each time a HTTP request is intercepted by the proxy right here, the HTTP module uses a combination of rail and fake certificates to prevent both the client and server from detecting that data has been modified. So when a user tries to log into or makes a request to log into the internet banking, a fake certificate is used so that the user isn't prompted with a message saying this certificate that you're trying to use is not real. They're able to use the malware is able to trick the browser by hooking functions within the crypt32.dll library. Here's an example of one of those fake certificates. So the victim's data is then caught by the proxy server and decrypted by the HTTP/HK module, where it is then modified to add malicious content. The HTTP/HK module encrypts the modified data with a real certificate and passes this on to the online banking website. Web server will trust this traffic because it actually is encrypted with a real certificate. So it's like, okay, this is fine. You can come through into my network or into my server. So that's when the malicious payload is dropped off. The HTTPI modules. This is where the screen capture and video capturing is initiated. So after the HTTP/HK module has analyzed the data that has been caught by the proxy server, and it detects that the user is trying to access an online banking website, it calls out to the HTTPI module, which then starts our screen capture or video capture session. Here's a list of all some of the functions that are used within the different libraries. This is mainly used when they're calling home for backup. They want to make sure that there's, for example, this one here, Internet Check Connect. Queries websites to verify if a valid internet connection exists. These all interact with legitimate processes on the operating system. This creates additional processes too, where the malicious code can run. Um, so you can create a process, create a remote thread, or write process memory. So the get message and transmit message are used in the key logging process. Get message takes commands or messages from user input, while translate message helps interpret these messages. So this pretty much anytime a person enters or types a key, that message that is sent from that input is recorded through these by these functions. And here's an example of the executable file that I was able to obtain. You can tell that it has a similar name to the file that was used in Czech Republic. And that ends my presentation.